Honestly, it's evening for a couple people for sure. All right, let me get my TikTok chat working, and let's get this one working. Should be up. Let's see. Test. Good. All right, cool. Chat works. How do I send a question to get help? Very good question there. Celebrando. So what you do, go to the website, actual officehours.com. One second, I need to like remove these. These are wrong. Yeah. Imagine how cool it'd be if civilization developed when Pangea was a thing and continents didn't exist. Yeah, it'd probably be pretty wild. So if you go here to the website, actualofficehours.com, it's linked a lot of places in the stream, but also I'll link it there in chat for you. Just type your username, drag an image, hit upload, and then that gets added to our queue. And so this is kind of a cool way for you to, you can boost your chances of your question getting picked by hitting this upvote button like every 3 minutes, and also the more time your question spends in the queue, the greater chance that we answer it. Let me translate. It's okay. You can submit it in whatever language you have. I'll translate it afterwards. So I'm also eating, like, dinner. Glizzy snacks. Okay. That being said, let's spin the wheel and see whose question we're going to work on today.
Let's go gambling!
Ooh, it's Broken Kidney. Broken Kidney, usually have difficult questions. What do you got for me? Find the least positive integer, which is a multiple 13 and all its digits are the same. Oh, that's cool. I think it's pretty dope, actually. Oh, if all the continents are connected. Oh, you're talking about, yeah, like if humans could travel really quickly to each other, that'd be pretty cool. Fine. So wait, it needs to be a multiple of 13 and all the digits are the same. This is where I just want to like brute force this, right?
No.
You're guessing 1 might be the answer, right? Well, so yeah, so when they say multiples of 13, right? So you could have like 13, 26, 39, blah 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 blah. You know, eventually goes down to like 169.
Nice.
But none of these have the digits being the same. Okay. The war with Iran. Yeah, but we wouldn't need to have the Strait of Hormuz, though, right?
Aw, dang it.
Right, breast skulls, we'd be okay. Okay. So, my question to y'all, the math folks. I mean, I'm kind of a math. I'm like a math light folk, like Chad light math. Is there a non-brute force way to do this? Or is this literally like, I'm just going to take my calculator out and just like keep multiplying by 13? Narosky says yes! Narosky, do you have a mic? Or sorry, I know you have a mic. Do you want to come up to the stage and talk about it? In a moment. Okay, cool. Let me flounder for a second. And then, we'll see what I come up with. Because here, I'll try the brute force method, right? Which is, so here, you can just type into your calculator, right? 13, and then you can say like plus 13, right? And then we could just do this forever. Until eventually we finally hit something that has the same digits. I could just do this like forever and ever. I just start spamming numbers. Yeah, right? Like 221 is close. 221 is close. JXNet says not geometric mean, but I'm thinking that type of series. Oh, like a geometric series maybe we'd get to it. Damn, like 299? It's very close. 442, again close. Okay, because this isn't really gonna work, unfortunately.
No.
Let's think about how, for instance, you figure out different digits of things. right? So, for instance, the number like 555. This is the same thing as like 500 plus 50 plus 5, right? And I need, so okay. So it's like A divided by 100 maybe, plus B over 10 plus C has to be equal to like some multiple of 13. So we could like say 13n. What's up, Icano? I think it's with a series. See if 13 divides the number 111. I think it's a string of ones, and it will be A equals A times 1, 1, 1, 1, 1, and A and 13 are prime. Okay, this is another, okay. Interesting. Velo saying that, like, okay, 'cause this is kind of my, like, if we just had, for instance, a 3-digit number, right? I need, like, A over 100 plus B over 10 plus C to equal 13 times N, and then, I need, A over 100 to equal B over 10 to equal C. Right, Narowski? Is this kind of like a way to think about it?
Yeah, it is. It is.
But, I mean, is it the correct way to think about it, or am I just being dumb?
No.
So, like, personally, I would let the number, like, we have to find the number n. It's a positive integer, right? Yeah. That is formed by repeating the same digit, let's say D,
okay,
exactly n times, right?
Exactly n times. Interesting. Wait. So it's the same thing?
We don't exactly know the length.
Yeah. So it's two different things, right? So we have like 13n equals, let's say A, I guess, right? But then times A times sure. A. But then this happens not necessarily n number of times, right? Maybe like m number of times?
Maybe, yes. But
okay.
If we have, let's say, maybe x, right? So we can differentiate. X would be that digit, let's say D is a digit between 1 and 9, okay, multiplied by 111 and so on, n times.
Okay, so let's see. So you want to say 13x, okay? 13x is equal
to not 13, not 13x. No, just
okay.
x.
Just x. Okay, so x is our number that we're looking for, right?
Yeah.
And that's equal to, we're gonna say 1. Oh, okay, I see it. Because if they're all the same number, right? Then that's basically some value D times 1, 1, 1, 1, 1. But we don't know how many ones are here.
So it's n times. So let's just say it's n times.
Cool.
Repeated.
Okay.
Right. This is what I was thinking of, and that number 1111 can be rewritten as a fraction.
Oh, interesting. Okay.
Yeah, because if you think about it, it's exactly 10 to the power of n minus 1 all divided by 9. Does that make sense?
Yeah, okay, let me think. Okay, so you're saying, because I'm seeing where the 11111 comes in, right? Because
exactly, because it's literally just
if I do 11 times 9
minus 1 divided by 9. Yeah.
Right, 11 times 9 gives me 99, right? 111 times 9 gets me 999. So this is always 10 to the something minus 1 divided by 9. Oh, very clever. Okay, very cool. All right, so Chris says, can you explain the 111 thing again? I think the 111 thing is that because all the digits need to be the same, it's always going to be some multiple times a bunch of ones. So for instance, 555, right? That's equal to 5 times 111. But if we had, like, let's say 66666, this would be 6 times 11111. So it's cool. I kind of think about this almost as like computer programming. If I want to ever build something that's all the same digits, I'm just multiplying something here times a bunch of 1111111s. It's really cool, actually. Okay. So let's rewrite this as a
This
fraction.
works. This works because d is a digit, right? It's a single. It's not
Yeah, d is an integer.
a number form, right? Yeah.
Right. Yeah, d has to be an integer. What's
An
up,
integer
history?
and also a digit. So it's exactly a digit long. That's why it works.
Oh, it's an integer. Okay, so digit refers to something just 0 through 9.
Exactly.
Perfect. Okay, cool. All right, so let me
But
write
it can
this.
be 0 because
It can't be 0 though.
Aw, dang it.
Yeah, because that wouldn't work. Okay.
So now we know what form our x has to be, and we want our x to be divisible by 13.
Okay, let's see. So 10 to the x, sorry, 10 to the n, sorry. 10 to the n minus 1, and then that's all over 9. We agreed with that. Okay.
Yeah.
Cool. And then what was the other thing we said? Sorry, it had to be a multiple of 13, right?
Yeah.
Okay. So do I put like maybe a 13x here?
I'm sure that you can realize that 13 cannot divide d.
Yeah, because this will be a digit, right? So nothing divided by 13 will get me something nice.
Yeah, d for digit, it cannot be divisible by 13. That would make no sense. So then the fraction has to be divisible by 13.
Okay. One second, I'm having someone on YouTube. There you go. Okay, so this whole thing, sorry, this part needs to be divisible by 13 because this will not.
Aw,
Right?
dang it.
Yes.
Okay, cool. So if this needs to be divisible by 13, do I just put a 13 on top?
No. So just say from this, right? So just or an arrow if you.
He's like, what's
Yeah.
the math way to do it? Well, I'll just say from this. It's okay. So 10 to the n minus 1 over 9 has to equal, I don't know, like 13 times a? Or
Do
like
you know
13
how to write divisible by?
I don't actually. No, tell me. You want me to do it with modulus?
Wait, let me see if I can actually write stuff. Okay. So I've actually got a pen and paper.
Oh, beautiful. We love this. All right, 1 second. Let me
Yeah,
go find your
so-
paper.
This is for you. I don't think the stream can see this.
Oh, I can see
Oh.
the stream can see it. There you go. You're on the stream.
Oh, beautiful. Okay. So the point is, right, this cannot be divisible by 13. We already know this. So then 13 has to divide 10 to the power of n minus 1 all over 9.
Okay.
Right? This is how you write divides.
Ah, okay. So that's the math way. I love learning like new math technology, math writing technology.
Yeah.
All right. Okay.
Necessarily, this is divisible by 9 already.
Okay.
We know this. So then we can just say that 13 divides what's on top. So 10 to the n minus 1.
Okay.
Does that make sense?
Let me think. Sorry. All right. So 10 to the n minus 1
This is-
over 9 divides 13.
This is because of this.
Okay. Let me understand this. Sorry. So 9 is a set. Is that what you're saying? 9 is a set. When you say that, they're like GCD,
I'm not
it looks
sure.
like that looks like GCD to me.
Yeah,
It's all-
GCD.
Oh, greatest common denominator. Okay, you know what's the funny thing
Exactly.
here? Your 9s and your G's look very similar.
Oh,
I was getting confused for a second.
Aw, dang
Okay,
it.
so GCD is okay. The greatest common denominator of 13 and is that sorry, things like coming out of
90.
90. Perfect. Okay, so greatest common denominator of 13 and 9D has to be equal to 1.
Yeah. Well, we know this because 13 does not divide 9,
Sure.
and 13 does not divide D.
Okay.
So 13 does not divide 9D.
9D.
So the greatest common denominator is 1.
Okay. 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 I think I see that.
So from this we can just say that 13 has to divide what's on top.
Yes. Okay.
This makes sense.
Right. Yeah. 13 can't divide the 9. I get it. Okay. Okay. So 13 has. Okay. So 13 has to divide 10 to the n minus 1.
So this means necessarily that this happens if and only if 10 to the n is congruent to 1 modulo 13.
10 to the n is equal to 1 modulo 13.
Yeah, basically just saying that
we
dividing...
we use like the parenthesis, we sometimes do this. We use the percent sign, right? Is that the same thing as 1 modulo 13? Yeah. It's like, I guess,
so basically this says that if you divide 10 to the power of n by 13, what you have left over is 1.
Oh, I agree. Yeah, okay. Because, 10 to the n divided by 13 should get you 1, and then minus 1 would get you 0. Okay, cool. Yeah.
That's basically what it's saying.
Okay.
So now you just have to plug a few numbers in, right? So you just go through, like 10 to the power of 1, for example, is just -3. This doesn't work.
10 to the power of 1 is equal to -3. Okay.
This is congruent to -3.
Wait, is 1 modulo 13 always... Sorry, 1 modulo 13 means always -12, no?
Yeah, I think we are not doing 1 modulo 13. We're doing 10 to the power of n modulo 13.
Oh, okay. Okay.
See?
Okay. Oh, okay. Okay.
We want to know what the remainder is.
I see. You want 10 to the n modulo 13.
Yeah.
Has to be equal to 1. Like this.
And we want to
right?
find the n for which this happens, right? So we're just going to check a few values.
Sure.
10 to the power of 2 is 100. Modulo 13, I think, is 9. Right?
Yeah.
Yeah. 10 to the power of 3, that's going to be 1,000. 1,000, right? Modulo 13, can you help me out?
Yeah, let me do it. Let me see. So, I would do 1,000 divided by 13. That gives me 76.92. So then I multiply by 76. And then, wait, sorry, no. I do 13 times 76. Sorry. 1 sec. Times 13. No. It's like 1,000 divided by 13 equals that. 76 times 13 gets me 988. So modulo is 12.
So it's 12. So it's -1. So it's 12, which is also -1.
Oh, wait a minute. I think I see what you're saying. Modulus can be positive or negative?
It can be positive or negative because it's what you have to add on to make it divisible by 13.
That's fascinating because I've only ever thought that modulus is positive. Crazy.
No, it can be negative. It can absolutely be negative.
Okay, that's crazy. Okay. I didn't know that.
This means that if we raise, basically what I'm gonna say here is that if we raise this whole thing, right? Because actually now we just have 10 to the power of 3 is congruent to -1 modulo 13.
I see.
Right? So this is what we have right now. And I'm gonna raise this whole thing to the second power.
You're gonna square the whole thing. Okay.
Yeah.
I see. Okay.
So if I square this whole thing, I'm just gonna have 10 to the power of 6, which is just congruent to 1. And we have found the n.
Oh, that's crazy. You know that's so I need to get better at doing modulus math. Modulus math is really cool. I see what you're saying here. Yeah. and then maybe let's show this on a calculator what like 10 to the 6 modulo 13 would be, right? So if you do 10 to the 6 here, I need to get better at remembering like what operations are valid under modulus, because it does come up a lot on like especially math competition questions. So you get that, right? So then if I do 7, 6, 923 times 13. I get, yes, there's my 99999. And that means it's modulus 1.
Yeah, exactly.
Wow, that's super cool. Okay, so n is equal to 6.
Yep. And we know it's the smallest one because we went through all the steps like in succession. So we know we haven't skipped any.
I mean, technically I could have checked 10 to the 4 and 10 to the 5, right?
Yeah, but they're not going to give you
They're just
what
not
you
going
want.
to. We just say no. Okay, fine. Python is faster. Yes, I know Python would work.
Also,
Surprise,
this is
motherfucker.
interesting. If you can also say that, for example, if 10 to the power of 4 was the one you were looking for example, so then you'd have 10 to the power of 4 is congruent to 1. Then, if you multiply by 10 to the power of 2,
I should have got negative
10
1.
to the power of 6. Yeah, you're going to have 10 to the power of 6 is congruent to 10 to the power of 2,
Well, that's
which is impossible.
Which isn't true, yeah.
Yeah.
Yeah, okay, cool. And the 5 is a little harder because 5 is prime, but...
Oh, no, because then if you just multiply by 10, you're going to have just 1 congruent to 10, which is false.
Got you. Okay. Oh, right.
Yeah.
Yes. Got you. Okay. Okay, so we know n is equal to 6, right? So now I have, what is that going to be? X is equal to D, and then we're going to say 10 to the 6 minus 1 all over 9, right?
Yeah.
Okay, brilliant. This here is 99999. 1, 2, 3, 4, 5. And then when we divide that by 9, very cool, right? This is going to become my one.
Yep.
Well, actually, I just know that just D is equal to 9 then, right?
You can just say D is equal to 1.
Or D is equal to 1. Yeah, sorry. Yeah, D is equal to 1.
Yeah.
Because that's the lowest version of it, I guess, right?
Yeah, this is what we are looking for.
Perfect. Yes, because then this divides out to 1, 1, 1, 1, 1 is equal to X. And then here, we can check that on a calculator. Is 5 ones divided by 9, is divided by 13, sorry. Wait. Well, wait, 1,
Is
2,
it
3.
5?
Oh, maybe it was 6. Wait a minute.
I think it's 6.
You are right. Right. Sorry, let's do that. Sorry, there's an extra one here. Sorry. 1, 2, 3, 4, 5, 6 divided by 13. There you go. Cool. Yes, and it's 8,547. Yes, 6 of them. Cool. There we go. Okay, so that's it. That's your solution. Nice. Cool. That's pretty dope. Nice proof. I just happen to know that 7 times 11 times 13 is 1,001, which helped me guess the right answer correctly. That's another way to do it, I guess, right? To have the intuition. I liked this proof better, though. This is pretty fun. This is something that, like, I'd probably need a little bit more practice for this to really... I get it now, but if you ask me this tomorrow, I'm not sure I would get it. I probably wouldn't get it right. But if I had done this a couple times in different situations, it would.
This comes with the virtue of doing like 6th grade questions for competitions. This pops up a lot.
I love how we call these 6th grade competition questions.
They really are. Because if you have the intuition of like anybody past high school, you're gonna have to, like, you're gonna work through it, but you're gonna get it eventually. A 6-year-old is never, like, a 6th grader, is never gonna get this. If they
exactly.
They're gonna make.
Yeah, no.
Yeah, they're gonna mess.
I don't think most 6th graders even know what modulus is, or let alone like
GCD.
I'm
talking about even the ones that go to competitions. Like their brain isn't big enough to handle all of the computations. Like physically, it's impossible.
Right. There's not enough. I don't think there are enough neurons.
Yeah, you're gonna mess up eventually. Like if you don't have the patience and the expertise of somebody who's older, you're not gonna brute force it.
Yeah. Yeah, that's cool. Yeah, this was super cool. Cool. Thanks, Narosky. I learned something from you. I always learn something from you, but you know that was especially cool. All right, nice. Whose question was this? Broken kidney. Broken kidney always are the interesting ones. Cool.
Yeah.
All right, we got 10 more submissions coming in though. Wow, that's a lot. All right, let me mark this one as done, and then let me save this into our. Modulus was just recently taught in my intro tech class, which is in high school, so 6th graders, yeah, they wouldn't know modulus, no. But wait, so, sorry, you call this a sixth grade question because one of the ways to solve it, brute forcing, could be done in the 6th grade. Is that what you're getting at, Narosky?
Yeah, I'm basically saying this is taught to students, or maybe like you're gonna meet modulus questions in high school, but that doesn't mean like somebody who's younger cannot understand this. I see. Because you're taught fractions in like the 6th or the 6th grade, right? So
yes,
you can basically do this. You can teach a young kid this, and they're gonna be able to understand it.
Right. I see, but they wouldn't have the capacity to find the modulus solution for it.
Yeah, unless they are taught beforehand what like modulus and remainder is.
Mm-hmm. Yeah, it isn't.
Because naturally, you're gonna, as a young child who's like aspiring to do these sort of problems, you're gonna have to ask like whoever's teaching you, like what happens if you divide a number and it doesn't give you an exact result, and you're gonna go down this path of trying to understand what the remainder is, like how they work together. Like this sort of stuff is taught like in Romanian high schools, but at a way lower level. I see.
And then you're kind of like figuring out what it is. You're basically like figuring out how modulus works without being taught what modulus actually is, like right up front.
Exactly.
Yeah, I get it. That's cool. You learn like the structure for it before you actually learn the formalism.
Yeah.
Nice. Yes, Blue, you're right. Okay, cool. All right, awesome. All right, wow, look how many questions we have today. Please vote for me. Here, I'll give you a vote. I will vote for you because you just said please vote for me. All right, let's spin and see who's gonna win.
Let's go gambling!
It's Mr. Silver. Okay, Mr. Silver, what do you got for me, dude? Man, is this another proof? Uh-oh.
Aw, dang it.
You guys, you math warriors, I swear. All right, let's see. Maybe Narosky, yeah, I feel like this is you. This is you, bro. Yeah. This is all you, dude, because this is planes, this is linear algebra, right?
No, this isn't. I think this is just geometry.
Okay, maybe. All right. Let's consider a plane divided into infinite families of strips by equally spaced parallel lines with distance between consecutive lines equal to 1. Okay. And they're parallel. Okay. The points inside each strip are colored either red or white, using only one color for each strip. The points on the lines remain uncolored. Prove that there exists an equilateral triangle of side length 100 whose vertices are points of the same color. Wow. Okay. Okay. Do I want to think about this like I know technically this is a 3D problem, but we can always consider like the projection of this plane into the 2D space, yeah?
I think this is just a 2D problem from the way
I think it is too. Yeah. Okay, so this is a 2D plane that is divided into an infinite family of strips. So let's draw some of the strips here. I'm gonna make the strips gray.
Oh, you know, this would benefit greatly if you had like I don't know how you call it, like, you know how when you have a math like notebook, you have the stripes perpendicular and
like graphing paper?
Yeah, graphic paper.
Uh-huh. Because what this is saying is that like some of these are red And then some of these are white, yeah?
Yeah, this is what I understand.
Yeah. And then I need a triangle whose vertices are all the point of the same color. Okay, so I need something that's like this, this, and this, right? Where like all of the... Actually, let's make the triangle a different color, sorry. I need something like this, 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 right? Of side length 100, whose vertices are points of the same color. Okay. Well, if it's an equilateral triangle, right, that means all the sides are equal, yeah?
Yeah, but the points of the same color, that's what's...
Well, right, because this is in red, and then this is in red, I think, is kind of what we want.
Yeah, but they're colored either red or white.
Yeah. So, I mean, technically, right, you could have the triangle over here.
Yeah.
Right, that would work as well.
This is actually difficult.
Okay.
Yeah, I don't know.
What's up, 1K? Yeah. So, I don't know. Maybe I would consider that one of the points, just for simplification, I'm just going to say that one of the vertices has to be on the x-axis. Yeah? That would just make life, like, kind of nice.
Yeah, I think you have to just construct your own triangle.
Yeah, let's just construct our own triangle. Let's just do it. All right, let's put one here. Treat 1 point on the origin. Yeah, I agree. Well, yes. Because again, the phase shifting of where my red and white is can be wherever. Yeah. But the other key thing here is that the points can't be on the line, right? So if we made but the lines are 1 unit away from each other, so you just have to like basically pick some fraction that you can't touch. Yeah. I think that's kind of how I think about it. Yeah, you only need one example for this to happen, right? Okay. So let's pretend. I want to put the center of the triangle at the origin. Ooh, interesting. Femfog, you want to do this for maybe for like reasons of R? To do this in maybe like circular coordinates? Polar coordinates, sorry. That would be an interesting thing to do. So we have a couple contenders here, right? And then use polar coordinates to find the angle at which all points are the same color. Correct. Yeah. And then if that's the center of the triangle, I guess twice that value would be the height. Yeah. So let's consider. Yeah. So we have a couple strategies people are talking about. So one would be to make the vertice here, right? One of the vertices there, and then try to build your triangle around that. Like something up here, and then this would be one way to do it, for sure. The other way would be to call this the center of your triangle. So let's say, I don't know, something like this.
Yeah, sorry I'm not helping. I'm just looking at my
You're
notebook, trying to imagine.
Oh no, you're
this would
good.
work.
No, you're good. You're
Like,
good.
the way I'm thinking about this is, you would simplify the problem a lot if you'd consider the, how would you call them, the edges of these bands, of these strips, to be integers, right? So if you have x to be an integer, then that's where the band either ends or begins.
Sure. And in that case, I don't want to use the origin as one of my vertices because I can't place the vertice on a band.
Yeah.
Exactly. Okay. We can do that.
Yeah, so basically each segment on the parallel on the x-axis basically would be just the interval n and n plus 1.
Yeah. So as long as we make sure that, yeah, that the vertice is not located on an integer value of x, or then we're okay. So yeah, I kind of agree with what Femvox says. Let's put the center of the triangle at the origin. Okay, let's consider that. And then, one second, let me put some more colors. And then if that were true, and then let's say the bands happen at every n, then you could think of something like, and I think I like Bresticle's idea of shifting this to polar coordinates. Do you think, Bresticles, we want to put one of the points on the x-axis? Yeah, you want to come speak? Come on up, Bresticles.
So what I was thinking was, in essence, a lot like how in finding roots of numbers in the complex plane, you imagine it like it's on a unit circle. In essence, think of it like that, but if you inscribed a triangle inside that circle and you were to just rotate that triangle, at some point those points are going to end up
all touching
meeting our condition.
Yeah, I see what you're saying.
So that they're not on those lines. So I think if we go into like a polar coordinate system with the center, we could basically
I like
rotate
this.
that triangle in such a way that we get
what we want.
We get it. Mm-hmm.
Okay, very cool. Okay, actually, I really like this idea, Bresticles. Yeah. So you're saying that, like, okay, let's say I'm trying to, in my diagram, this isn't going to work exactly yet. I have to, like, change the radius of the circle. But then we can, like, scale it up. All right. I don't know. Say we got something like this. Yeah. Yeah, like that. And then, yeah, assume this is the center of the circle. Then as I spin this thing around, we'll have the vertices, like, entering different bands. Okay.
Mm-hmm.
And then the condition is that the side lengths have to be 100.
Yeah, that's what's messing me up, because you can definitely find a triangle. But how do you construct it such that the
well, if it's an equilateral triangle, right, it has to break these arcs into 120 degrees, right? So from that,
or the way I'm thinking of it is like more complex analysis, right? If you draw like your unit circle and all of your roots, you would have an equilateral triangle in there, but it's going to end up on one of those lines. But you could add an angle to that, and then you could just use your Pythagorean theorem to find the radius of that. So now in like in complex form, right, you get your RE to the I theta, and then you can just figure out that pretty much any theta, if you just add a little angle to it, it's going to push it off of that line.
I see.
And as long as that value isn't a whole number,
not an integer, you're okay. Yeah, okay. What do you think? The roots thing. Roots in the complex. Oh, I see. Because would it be the third root of something?
Yeah, because your third root, whenever you take a square root and you consider the complex roots,
Mm-hmm.
It's just evenly spaced along that unit circle.
Yes.
So like
Yeah, 'cause
square root of
basically-
1 would have a root at plus 120, plus 120, and then back to
Yeah, because
360.
if you consider so basically the XY plane, right? The XY plane is basically
Yeah.
just the complex plane.
Right. This is the real
what
part.
you're
This is
saying.
the imaginary. Yeah, I get that.
Yeah. So if we assign like
The cube root of r. Is that
Yep.
what we're gonna do? Like the cube root of r.
Mhm.
Okay. And then that would give me three. That would give me 3 roots, right? And then.
Yep.
And then yeah, okay. I can move those around to try and make the condition work. And then how do we do? How do we do that? The length is 100 though.
I would probably just break the what's called the equilateral triangle into 2 right triangles, and then use Pythagorean theorem.
Oh, okay. So maybe just do it this way, right? Like just pretend it's like this. Or actually, wait a minute. Sorry, let me think about this. Cube root of r. I think this is what happens when you do the cube root. It's just like the basic cube root before you do any phase shifting. I think this is what it looks like, right?
Yes. Yeah.
Uh-huh. Because then, yeah, you get like a plus I and a minus I version of it. Right. Okay.
And then we could just figure out the
We can figure out
R
this.
in some way by just figuring out where the center of the triangle is.
Mm-hmm. Oh, okay. Oh, okay. If this is an equilateral triangle, and if this is the center of the triangle, I know this is not really drawn to scale, but this whole length here would be 2r, correct?
I don't know if it would be 2r. It would be, if we say like the side or the amount on the left is like a or whatever, and the amount on the right would be r.
Or it would be, you say
Because
a plus b equals r?
No, a plus r equals the total height of our
Yeah.
triangle.
JC, if you want to get on the call, totally can. Join the Discord and just I'll promote you. You're good. One sec. Let me go through chat real quick. Celebrando says, chat, could someone make a favor? I'll go to sleep now. My question is on Portuguese, but it uses expressions. Celebrando, if you just submit a screenshot of your question in Portuguese, I don't care. I'll translate it. Just if you get it in the queue, then we'll get to it. That's the best way for us to help you. JC says, okay, JC has like an easy solution, but here, let's get JC up here. I got the math, chemistry, Avengers coming on up. What's up, JC?
Yo, what's up?
What's up?
Hold on.
All right.
So, right, can you like draw?
You want to make a new?
of
I'll
what
make
you
a new
have?
thing. Yeah, make a new thing. We've massively complicated this.
Aw, dang it.
Okay.
No, genuinely, like drawing like a circle and all that.
Okay.
This time I want you to put like a red stripe like straight down the middle.
Okay. At x equals 0.
Yeah. So like
Okay.
with like a width of a half on each side.
Oh,
And then that's
you want a candy cane? One sec. I got you.
Yeah.
I got you, bro. You want like this. And we're gonna say that this has a width of 1.
Yeah, that has a width of 1.
Perfect. Okay.
Right. Now I'm gonna put a vertex of the triangle like right at 0, 0.
Oh, okay. Oh, that's cool.
Yeah.
That's legal. I'm cool with that. Or let me
That's
get a better
legal,
color.
right?
It is legal.
And-
That is legal.
Suppose that we have, right? I mean, we do have a triangle with an even side length, right?
Yeah.
So if you just draw out like a side horizontally to the right, if it's even, then the other vertex must land on a red stripe. And so if it's 100,
okay.
it also lands on a red stripe, right?
Oh, Jesus. No, JC. JC is too easy, dude. What? Okay, I see. All right, so you're gonna put this over here, and say that, yeah.
Yeah.
Actually.
For simplification, let's do like a side length of 4 because I think it's important that it's divisible by 4.
You think it's important that it's divisible by 4? Okay.
Yeah. Right.
So you're gonna
let's
call
say
this
that length
4.
is 4 right now. Yeah. Now imagine the midpoint of those two vertices, right?
Okay, that would be here at 2.
That would be here,
Right.
and then my third vertex would lie on like that perpendicular line. That's on my midpoint.
Is this gonna be an equilateral triangle though?
I can force it to be one.
Oh, okay, all right.
And I know that because it's this whole thing's divisible by 4.
Yeah.
The midpoint is also red.
Correct.
Does that make sense?
Okay. Yeah. Because this is at 0, and
0.
then this is like a half. So then the next one is a half to 1.5, and then the next one is 1.5 to 3.5, right? So that's going to be at let me get that there. 1 second.
Yeah. As long as they're all like evenly spaced apart, they must all be red. Right?
Correct. Here, let me.
And my top point there is unrestrained. Like I can change the y coordinate of that until it becomes equilateral.
Let me see. This one. Yes. Okay.
Yeah,
So yeah,
I can
you
just,
could
like, slide it
you can
down.
move this around. Yeah. Until
and
you
it'll
get
definitely
an
still be red.
equilateral triangle.
Yeah.
Okay. I agree
So
with that.
as long
Yeah.
as my side length, because I mean, it doesn't change if it's 100. So in the case that it's 100, both coordinates will still be red,
I see.
and the
I
midpoint
see.
will be red.
Yeah, or you could just have the top or the origin be the top point, and then
Oh yeah, that could
on the
work
bottom
as well, yeah.
right, your bottom right vertice is gonna
It's
go
just-
down.
it's just somewhere
and then
down
it's gonna
here.
go 50.
Yeah.
It's gonna go 50 to your right.
Yeah, and because
Which
50 is an even number.
Even so, it's
Yeah.
on a red
Wow.
stripe. 50 to the left, it's also on a red stripe.
Wow. Okay. That works too. Okay. So So you're saying we could do this,
Yeah.
and then make
I think-
this. Go on, JC.
I wonder, right? Because what you were trying to do is you were centering the triangle in the middle. It might
Yeah.
still be possible if that was an extra constraint. I don't know. But it's just saying that there exists some triangle.
Yeah, we just gotta find one.
So-
Yeah, so you just
Yeah.
have to have one.
Fucking get me one. It's all I need. Okay. So I see. So if we say that this distance here is 50, which
Mhm.
is not divisible by 4, but it's divisible by 2, which is cool. That's all
Yeah,
I
it's
need.
even. So the
It's
midpoint
even.
must be red. Yeah.
I got you. Okay. Awesome. And then this distance must be 100.
Well, you would bring that dot on the top right, bring it to the bottom left,
Bottom
right?
left.
So that so it's basically just an equilateral triangle, just like sitting there. No, like 50 to the left.
You bring it over here?
No, bring it
Wait, what?
down to the bottom.
Yeah.
Right under the origin.
Oh, right
Down
in the
from
origin. Yeah.
No, down from it.
Down here? This is 50 down.
Yeah. Now go to the left, 50.
Oh.
It's just an equilateral
Oh,
sitting
okay. Now we're cooking. Okay, I see. Because this whole thing is 100 now.
That
Okay,
whole
great.
thing's 100, yeah.
Beautiful. Okay, so then this is 100. Okay, so then we just need this thing to be 100, which is Pythagorean theorem, right? Or distance
Yeah,
formula
or
or something.
I think you drop it down by like √3/2.
Oh yeah, because it's equilateral, 60 degrees.
Yeah, something like.
Yeah. Okay.
Well, I mean, we could at any point on that strip, it still works
Yeah.
because you can just move that point up or down until the distance is correct.
You're talking about the origin point. The origin point I can move up and down.
Yeah, you could just move it up and down. And
Oh,
you
okay,
can
cool.
Find your origin at any point.
Oh, I see. So wait, I could actually just put this here, no?
Yeah, you can.
And then
put that
and then we
there
just move and then we just
And
move this.
Yeah.
Ah, even better, boys. Okay, cool. Yeah, I like that. Okay, so yeah, the points
Yeah.
would be.
Okay, I'm a dip.
You're good. Thanks, Joseph. He's like,
Bye.
yep, you got it. You got it from here. Appreciate it, Joseph. Okay. So you have negative 50, comma 0, 50, comma 0, and then, yeah, in order for the height here, I do agree. If this is an equilateral triangle, then this needs to be 60 degrees. And so this would be 100 sine 30. Would be equal to this. So that would be equal to 50 square root of 3. Okay, so then your points are minus 50, 0, 50, comma 0, and then 0, comma 50 square root of 3. Yeah. Does that look good? Does that look good to you guys?
Seems correct in my books.
All right, nice. We're going to call it. Mr. Silver with the fun one. Wow, that was cool. I still liked I liked the complicated land we were going here. We were drawing like satanic pentagrams.
I like the complex analysis solution. It seems more fun.
But in typical fashion, leave it to the Brits to be like, well, actually, you could just do it this way. I'm just like, oh, okay, that is a lot easier. This was like, I feel like it's that one meme of like It's Always Sunny in Philadelphia where he's like trying to like connect the red lines and be like, yo, it's all connected. Genuinely, why are we rotating? What's up, Narowski?
I feel like I want to argue, but I'm not sure why.
Aw, dang it.
He's like, it's too easy.
It's suspiciously easy.
It's suspiciously easy. It makes sense to me.
It doesn't really solve the coloring problem.
What do you mean it doesn't solve the coloring problem?
Okay, so let's say like our boundaries are of the form an integer plus a half, right? So if it's x equals k plus a half, right?
Yeah, I agree.
Then our point, that is 0 and 50 square root of 3, is going to lie in the middle strip.
Which is legal. That's totally legal. We're allowed to do that.
Negative 50 and 0 lies in the strip negative 50.5, negative 45.5.
Uh-huh.
Anyway, like they lie in 3 different strips.
Oh, do they have to be in the same strip? No, they have to be just the same color.
I'm saying like nothing is saying that all of these 3 strips have the same color.
Oh, you're gonna argue by parity.
Because it could be red, white, red, or white, red, white.
Oh, well, okay. I think the argument is as long as it's even, as long as you're an even distance away, you're gonna be in the same color, right?
Yeah, because then, like if you prove this, like a valid method of going about this would be 2 vertices in the same strip, and the third one in another strip, and then justify why that second strip has to be the same color as the first.
I think, and that's what JC was doing originally when I think he was doing it this way. He was saying that these two have to be in the same strip.
What we did here works. It works, but it's not like it doesn't satisfy.
It's dirty. You know, it's funny. JC came in originally saying that let's do this and this and this, and then Breskels was like, wait a minute, let's make it even easier. Let's do it this way, which I approve. I think it's very cool because then you only have to move 1 point. But you are right that it is a little more shaky because now you're putting all the vertices in 3 different strips. But they're valid.
It just doesn't work.
But they're valid. They are valid though. It's valid.
Yeah, but it doesn't work.
What do you mean it doesn't work? Wait, this doesn't work? Why does this not work?
No, it doesn't work because it does have a side length of 100, but
yes.
What says that the 3 strips are of the same color?
Because they're an even number of distance away from the origin. No. 50 is divisible by 2.
I could have like 5 strips of the same color and then 100 strips of a different color.
Okay, one second.
I think they have to be alternating.
Yeah, interesting. Okay, no. I get what he's saying. Okay, are colored either red or white. Interesting. Okay, it does not say they have to be consecutive. Okay. Wow.
Yeah.
Okay. Oh man.
Oh, dang it.
Man. Yeah. Oh, dude. JC's like, oh.
But I guess. But we only have to prove that there exists one with these specific conditions. So we've still shown that there is one way that you could set up.
There is one way you could do it. I mean, the other way I could have done it. I could have made all the fucking strips red, and then just put a white one all the way at the end.
It's the same thing. It's the same thing. And you could have said proof by look at it.
Okay, then. Well, in that case, I don't think anything's solvable then, right? Because even if we were to do this, Narosky, right? Even if I were to put one here and one here, who's to say that this one, or sorry, whatever, wherever this one is, who's to say that one's also the same color?
No, because this has to be a proof by contradiction. There is no other way.
Jeez.
Like you need something that's forcing.
That forces them to be the same color?
Yeah,
so
you need something that forces them.
Oh, wow. See? Man. Why can't they just be alternating? Okay.
Because I don't think it would be. I don't think it's. It would be interesting enough to submit the question.
Okay. All right. Well, here, I'll leave this as an exercise for other people because there's 9 questions in the queue. But
I mean, if you'd want to listen to me, like, try this for another 15 minutes, sure. But otherwise,
yeah. Maybe later in the stream. I just want to make sure because we already. How much time have we already spent on this question? We've already spent 30 minutes on this question. If I dedicate another 15, it's just not fair to everyone else.
See, that's why I kind of like the complex analysis version. Because if we say, let's take a really small version, or really small value epsilon, and add that to the angle, then we're still guaranteeing that it's not on a line.
Yeah, like that could work. Yeah. But then again, like the easiest way I could think about this, right? It would be like just taking parallel lines with integer boundaries, have the set of strips denoted as something, and say its color is maybe C, right? So it has an arbitrary color. It's either red or white. And then just pull out some numbers from the fact that it's an equilateral triangle, right? So let's say that the color C of n is going to be the same color as C of n plus 86, for example.
Okay.
Right, because then you can then choose a number. Let's say, I don't know, y, between 0 and 87 minus the 50 square root of 5. And then choose your points, A and B, to be 0 and n plus y, B to be 100 and n plus y. So then AB is 100 and the height is 50 square root of 5 and it's equilateral.
Mm-hmm. And then JC says he solved it again. Wait, JC says he solved it again. Oh man, you guys, stop.
Oh, dang it.
Trust. Okay, wait. JC says trust. Okay. All right.
Okay, we trust JC.
We trust you, JC. Do you want to? Here. Let me do one other person's question. If you have it like written down, can you just write it down for me, JC, real quick, and then I'll come back to it. I'm
gonna write it down as well because it's
awesome.
a lot of notation.
All right. Yeah. Let's choose a winner for the next question. I do love these. These are great, but also want to make sure we do other people's stuff. Nice. It's the Brazilian Celtrabayando. Okay. More geometry. You guys are hitting us with all the geometry today, dude. I think you just flip the strip sideways and do it that way. Dude, this question's funny. Who gave us this question? Mr. Silver? All right, let me see. Okay. This is in Brazilian. M is punto medio, is a midpoint, and the triangle is equilateral. ABCD is a quadrilateral. CF is a Umareta. One sec. You know, he put this in our chat somewhere. Let me go find it. All right, one sec. Okay. Let me see if I got this. Okay. The triangle's equilateral. The square and the triangle have a side A. Okay, they both have the same side A. Okay, cool. M is the median of the side. Okay, so the midpoint of the side. Oh, and this is a square. Cool. And you have to find the area of the blue triangle as a function of A. And this is also an equilateral triangle. Okay, cool. All right, I don't think this is too bad. Well, maybe it is. One sec. TikTok mad at me. A. So then this distance here is going to be A over 2. All right, let me put it in colors. A over 2. And then there's a line. Yeah, just putting C at 0, 0. I agree. This is... Where's Jeff, dude? Jeff loves his coordinate systems. Come on, Jeff. Where are you at, dude? Jeff loves coordinate systems. Okay, let's just call this 0, 0. And then we're going to call this A, comma 0. And then we're going to call this A, comma A over 2. Right? Hey, what's up, Jeff? There you are. Nowhere to be found. And then... Well, if it's an equilateral triangle, this is always going to be shorter than this, I believe. Right? There's no way there's no way this triangle can have the same height of A. It's got to be like this. Thanks for the follow, Endeavors. I know you've been in our stream for a bit. Is it your first time on Twitch? You've been in our Discord for a bit, dude. That's what I would say. Okay, and then you want the area of this. Oh, very cool. Okay. Do I maybe want to like come up with the equation of this thing as a line to find the intersection point? Let A equal 1. I need to do it as a function of A though, Fem, right? I was thinking of, so I know the area of this triangle, right, is going to be 1/2 base times height. I just have to find this intersection point, no? Right? And so I know that the base is equal to A over 2 from here, right? Oh, the triangle matches the top square on the graph paper. Sorry, what are we talking about here? Yeah, but I don't think that's possible because they said this is an equilateral triangle with side length A, right? So there's no way this thing can also have a height of A. It wouldn't be possible, right? So here's another thing. Okay, I know this is point A, comma 0. Yeah, the diagram's not to scale. Oh, yeah, look at that.
Oh, dang it.
Okay, so then this would be at 3/2 A, right? Comma, I don't know, square root of 3 over 2 A. Well, wait, yeah. Square root of 3 over 2A. Thank God I'm not doing math. I am building an algorithm. Yes, we are building an algorithm. This is how my brain thinks. I try to think of this almost in like a computer science type method of like, you know, what's an algorithm? How do I build this in terms of points? It's a little brute forcing. I'm sure there's maybe a nicer way to do this one, but in my mind, I'm like, well, bro, if I have the x coordinate of this point, then I know the height of this triangle, and then we're done. So I just need to get that. So how do we get that? Well, I know the equation, right, of this line. So this is going to be y is equal to, so it's going to go, the slope of this line is going to be a over 2 over a, right? So that's just going to be equal to 1/2 x plus 0, right? That's the equation of that line. And then the equation of this blue line, okay? The slope of that, so you're gonna have, this is where it's a little, I guess you want to do some like point slope form maybe, right? So the slope is gonna equal square root of 3 over 2a over 3/2 a minus a, so minus 1/2 a, or sorry, minus just a, no, 1/2 a, right? Changing y over changing x. And so that's just going to equal to square root of 3. And, okay, so if we want to put that in point slope form, that's y minus 0. It's equal to the square root of 3. And then that's going to be x minus a. Yeah? I think that's good. And then all I need to do is solve for x here, right? Because then once I get x, then I instantly know the height of this triangle. Let's see. Abdullah says, couldn't you just work out the angle between the square and the equilateral triangle? It should be equal to 30 degrees. And then you use trig. Yeah, no, I agree that this... Okay, so Abdullah's saying... So maybe this is a smarter way to do this question. Multiple ways to skin a cat. This is 60 degrees. I agree. So then this must be 30 degrees. And then... But, okay. And sure, I know this. I know this. Don't I still need... I still need this, I think, to figure out the area of the triangle, though, no? I still need what this point is. Or is there another way to do it? I don't think so. Yeah. Still need a little bit more, I think. Okay, so you have... Is the blue triangle isosceles? I don't think so. I don't think necessarily. I don't think we know that it's isosceles. We know that this goes through the midpoint of this line, right? Because that's a 30, 60, 90. This is not 90 though. This is probably like a competition type question. Okay. Okay, just one sec. So moved over, you get 1/2 minus the square root of 3 times x is equal to negative square root of 3 times a. Divide out. So x is equal to, I'm going to get rid of the negative. I'm going to say square root of 3a over the square root of 3 minus 1/2. Okay. And then if that's the x coordinate, then the height of the triangle is going to be equal to x minus a. All right, whatever this x coordinate is, minus a will give me the height of the triangle. Okay. So that's going to be equal to square root of 3a over square root of 3 minus 1/2 minus a. Cool. And then let's multiply that all the way up here. All the way up. Okay, so I think your final answer is... It doesn't look pretty.
Aw, dang it.
Which could be wrong. But I think it's this. I think it's 1/2 a over 2. And then it's all this stuff. Maybe we actually, let's see if we make this a nicer denominator though, right? Because I can move that up top. All right, so wait, this is the same thing as square root of 3a minus square root of 3a plus 1/2 all over square root of 3 minus 1/2. So these cancel. And then I'm just left with 1/2. So 1 over 2 square root of 3 minus 1. Okay. Whatever, 2 square root of 3 minus 1. Cool. I think this is the final answer. Someone tell me if I think differently. Otherwise, I'm going to call it. Nice. Narosky's written up a solution for the last one. Let's go check that out in a sec. This was Celtar. And then again, every time we do one of these questions, they get posted in our Discord. So here, for instance, you'll see this was Celtar's question. We're going to drag in the screenshot from what we did. And then also there's a nice little YouTube link that shows a little live replay of what happened. Bro, just using the mod function in Excel? What's the mod function in Excel? Okay, let's see what Narosky has brought for us. Okay. Wait, answer should be in terms of a squared though, not just a. It is in terms of... Oh, sorry. I forgot there's an a there. Wait. You are right. Sorry. There's a 1/2 a. I messed up. One sec. Yeah, let me fix that. Thank you, Fem, for picking that up. Sorry, this should have been 1/2 a. There we go. This is a over that. Yes. Thank you. There we go. Now it's correct. Leave it to me to just make like a silly algebra mistake at the end. Yeah, I just forgot the a. Okay. What is Kirchhoff's loops? The Kirchhoff's loops laws? Kirchhoff's loop laws are great. Be good for figuring out circuits and stuff. All right, let's see. Sorry, let me see what Narosky wrote here. Okay, let the parallel lines y equals n, and n is a integer. Okay, so the stripes are x, y, and n is less than y is in between n and n plus 1. Okay, cool. So that assumes that the stripes have to have a width of 1. All right, I'm cool with that. Let S of n be red or white. Let C of n be its color code, right? Which is red or Y. We can prove by contradiction. Ooh. A proof by contradiction. Okay. If Cn equals Cn plus 86, then there exists a monochromatic triangle of length 100. Okay. So okay, let me remember like how proof by contradiction works. Proof by contradiction works by you're going to show that if this was true, that you would get a nonsensical answer, and that means it can't be true. Right? Are we like proving that the triangle doesn't exist?
Yeah, our goal is to say that there doesn't exist a triangle that meets those conditions. And then at some point in our proof, we would contradict something and say that, well, because we ran into this contradiction, that there has to be a triangle.
Then there has to be a triangle. Okay. All right. So the claim is, I'm curious about the 86. Oh, I guess you picked 86 because it's in between the. It's okay. It's between 50 root 3. That's why. Okay. So if Cn is equal to Cn plus 86, so if the nth one and then 86 segments over, they're equal to the same color, then there exists a triangle of length 100 that is monochromatic on the vertices. Indeed. Okay, choose 0 is less than alpha. Alpha is between 0 and 87 minus 50 root 3, which is possible because 86. Oh, sorry. I think you're saying that. Sorry. Let me think how this is working. Possible because 86 and 50 root 3 is between 86 and 87. Okay. So you're putting one of the points on 0, n plus alpha. The other one. So sorry, you're choosing alpha is equal to 50 root 3, I think. And the other one's at 100 n plus alpha. And since AB is equal to 100, okay, good. And then the height is 50 root 3. Then ABC, where's C though? Oh, okay, C's the one. C is at 100 and minus alpha, maybe? It has to be, right? ABC is equilateral sides 2. Wait a minute. Sorry, I gotta draw this. Let me copy this in for Narowski. Okay. So you're saying A is at 0, n plus alpha, where n is, again, any integer. Oh, Narowski has more. Even simpler. Okay. Let's go through the even simpler way then. We've distilled it down. Okay. Even simpler. Okay, let's construct a coordinate axis such that x is equal to n, and n, I don't know what this symbol is. N
is an element of the integers.
An element of the inverse? What does that mean?
Integers.
An integer. Yeah.
Oh, sorry, my bad. Okay, n is. Oh, this is you saying z. Got you. Okay, cool. All right. Is the equation of the edges between the bands. The edges between the bands. We associate each segment on the x-axis or the form, and n plus 1 the form, the color of its band. It's sufficient to find a triangle with a vertical side. So to find x such that x and x plus a, where a is equal to 100, square root of 3 over 2 are segments of the source color. Let's suppose the contrary. Suppose segment 0, 1, and b plus 1, where b is the floor of a, have different colors. In this case, b comma b plus 1 and b minus a comma 0 have different colors. So we get a monochromatic triangle in the semi-plane x is less than 0. Ooh, I don't know if I understand this one.
Oh, dang it.
My brain. I want to get to this level at some point. Y'all speak like almost a different language. Yeah, I don't know if I'm gonna get it. Okay. I think I was close understanding this. I was close. Because I understand that like 50 root 3 is...
Maybe leave the second method for the person who submitted.
Yeah. Let me do it. Here, I'm gonna copy this in for Mr. Silver. Okay, I'm gonna copy both your solutions. I appreciate you writing them up, Narowski. No, they're great. Don't feel discouraged by this just because I'm too retarded to understand this sometimes.
No, because the second one I agree. It's shorter, it's simpler, but it's way harder to come up with.
Sure.
I only came up with it after I like understood the problem and did the simpler solution and the longer one.
Okay. So it's a cooler, more like elegant solution to it.
Yeah, basically. Like after you already know the answer.
Yeah, hindsight is 20/20, right?
Exactly.
Yeah. Isn't the logarithm the powerhouse of the cell? No, dog.
Oh, dang it.
No.
That's the mitochondria, dude. That's the mitochondria. Everyone knows the mitochondria is the powerhouse of the cell. It's a common meme.
Yeah, so basically we're gonna show that by contradiction.
Yeah, okay.
We're gonna have a plane colored entirely by the same color.
Oh, you can have it all be the same color. So everything here is just red.
That's what I'm gonna try to force, and that's gonna be a contradiction.
Because you're gonna say that there has to be at least another color somewhere else, right?
Yeah, otherwise it doesn't work.
Okay, cool. All right.
Because
So
we're supposed the way we're gonna do this is like by double contradiction, like if that makes sense.
double contradiction? What? Like the negative of a negative is a positive.
Basically, yeah. Because you're gonna suppose that there isn't any triangle of this, like equilateral triangle with side length 100, and it's monochromatic, and you're gonna show that eventually you get that there is one, which is a contradiction, but it's actually what you wanted to prove.
I see. You're gonna prove. Well, I mean, obviously, if the whole thing's the same color, there could be one, right? That's easy.
Yeah, but you're supposing there isn't one, which is a contradiction.
Oh wow! Let me wrap. Okay.
Yeah, it should make more sense now.
I see. You're saying that like, oh, if there was only one color, there shouldn't be one, but there is one.
Yeah.
Dude, that's so clever.
My man.
Oh, okay. I understand it now. I see. Because the conditions of the problem is that we have to have alternating segments. And you're saying that...
Yeah.
Oh, okay, cool. So if there weren't alternating segments...
Yeah, it's not a contradiction because we have to have alternating segments, or we have to we don't have to have any white at all.
Yeah.
Right? We can have a whole plane full of red.
Mm-hmm.
But then we are saying that in our hypothesis that there is no triangle.
Yeah, it doesn't exist.
That's monochromatic and equilateral. But if the whole plane is forced to be red, then what we are saying is baloney. So.
Wow. Yeah, that's
basically a double contradiction.
It's cool. That's some logical. Yeah, JXNat's like, he's like, I don't understand what's happening right now. Did we find it, or am I retarded? Bruh. No, you're okay. What JXNat? What the high? You're right. We did find one. But this is called like being, I guess, like complete or like closed in the argument. Is that technically we weren't told that the strips were oscillating. That's some cute little unique case that we used. So what Narowski is going one step further is to prove that this actually works for man, TikTok. Now they're restricting me for hate speech. Okay, fine. What did I just say? That's hate speech.
God, what? Okay, fine. I can't get like too upset, I guess. Anyways, what? Yes, what's up, Pen? Yes. Shout out to Pen Center. It's just so funny. The second I say something like that, dude, the TikTok overlords instantly like start flagging my stream. They're just like, you're promoting hate speech. I'm promoting math, dog.
This is not hate speech. Anyways, all right. JHNat, what Narosky is doing is showing that this would work for. This has to work for, I guess, any arbitrary combination of red and white things, because you're proving that if it couldn't work for all red, but because the opposite of it works for red and white is that it shouldn't work for all red. There's like two situations, right? Either you can build the triangle and like your pattern is reds and whites. And so what we're saying is that like if it's all reds, then we shouldn't be able to build the pattern. But if we can build the pattern, that means if it's all reds, we shouldn't be able to build the triangle. But because we can build the triangle, that means the pattern must be reds and whites, and then that's what we're looking for. Yeah. Did I kind of explain that, Narosky?
Yeah, I think you understand what you're trying to say, because what we're contradicting is that basically we're saying that there doesn't exist a monochromatic equilateral triangle of side length 100 under the conditions that were given.
Yeah.
Now, we go one step further and make two claims. The first claim is that if, let's say, color Cn is equal to the color Cn plus 86, so 86 bands ahead, it's the same color as this one.
Yeah.
We prove that can't happen because we can find an equilateral triangle in this case, but we're saying there isn't one, so
right.
It doesn't work. The second claim is the same as the first, but n plus 87. If you look.
I see, yeah.
Right, so now, if we go back to the first claim and just go, instead of n, we're gonna say n plus 1.
You move it up.
Then n plus 87 has the same color as n plus 1.
Yeah.
Right, it doesn't have the same color.
It doesn't have the same color. Right.
Yeah. But by the second argument, the 87th color doesn't have the same value as the nth color.
Yeah.
Right? So we have found a band that has a different color from both Sn and Sn plus 1.
Yes.
So that means Sn and Sn plus 1 have to have the same color, otherwise we have three colors, which is false.
Got you, okay.
Oh, dang it.
I got you.
So because we chose n to be any arbitrary integer, having two consecutive integers equal means the whole plane is colored the same way. Which is false, because now we can find any equilateral triangle, let alone one with side length 100.
Right. I see.
We were saying that there doesn't exist any. So
yeah.
What we're saying is false.
And then that contradiction proves it's like a double negative. Now I proved what I wanted is true.
Yeah.
Cool. I thought it was cool.
Perfect.
This
Nice.
is actually something I'd see. This is something I'd see at like nationals in my country. It's crazy.
Yeah.
I don't know where this is taken out of.
I don't know. Someone, Mr. Silver, dude. If you're in my chat, Mr. Silver, where'd you come up with this? Tell me, please.
This guy just saw. He saw Dr. Gold and said.
He's like, I'm gonna hurt
Silver.
this man. I'm gonna hurt
The
this
silver
man.
pure gold.
It is. This is like, yeah. But I've come out stronger from it.
Yeah.
Okay, cool. Silver just dropping JEE advanced questions. I don't know if that's JEE. It is definitely like it's definitely.
I think that puts JE to shame. Honestly,
wow, puts JE to shame.
You done messed up, AA
I would go that far.
Yeah, that's crazy.
There's too much ambiguity in it. I feel like in the way they worded it.
Yeah, like you have nothing. You have nothing.
Possibilities.
Absolutely nothing.
They didn't even necessarily say that the strips had to be vertical either.
Yeah,
They just said they had to be
really didn't
parallel.
have to be vertical. They
No.
could be horizontal.
They said they had to be parallel though. It did say they had to be parallel.
Parallel.
Yeah, but you could rotate parallel lines in any direction.
Exactly.
It could be a 45-degree parallel line.
Sure. And then that's your rotation argument though, because I was saying that like they said it was in a plane and they're parallel, so you could just re-rotate your coordinate axis to make them parallel.
Yeah.
Yeah. Or make them vertical. Sorry, that's what I would say. Yeah. Okay. Let's see who we got next. Go choose winner.
Let's go gambling!
Yeah, you just rotate the frame, right? Yeah. That's right. Wow, more pain, breasticles!
This one's not terrible.
This one's not terrible. Beautiful.
Yeah, I didn't feel like writing out the question. The question is to
What are
derive
Maxwell's
the
equations?
wave equation from the integral form of Maxwell's. That's just a screenshot straight from a paper I had to write. So
Okay, you want me to derive the wave equation?
derive the wave equation from Maxwell's integral equations.
Interesting.
So you go to the differential form of Maxwell's equations and then to the wave equation from there.
So are we allowed to use the derivative form, or do I have to like rederive the derivative form?
Yeah.
Oh. Okay.
I don't really care the way. I just
Just want to see it. That's cool.
But you could use the
Let's see.
differential form. Hold up, I can send you the differential form. I have both of them.
Oh yeah, but okay.
Yeah.
I mean, it's these, right? These are the derivative forms. Or here we go.
Yeah.
This has the full stuff in it. Or just tilt your head a bit, dude. Is this papyrus, dude? Did someone write this with papyrus?
Disqualified.
Man, dude, what? Ah, okay. Yeah, they don't include yeah, okay, gotcha. Okay, it's actually the same stuff. Okay, cool. Okay, and then what's the wave equation? Something like d squared dx equals something d squared dt or something.
It's Laplacian of x
Laplace.
is the second time derivative.
The Laplacian. Oh, okay. Wait, one second. I know
Yeah,
what you're talking
you're
I heard Laplacian, I instantly started thinking about Laplace transforms, and I was like, because I've been watching Zach's stream earlier on Laplace transforms. Whole bunch of phi's. Yeah, it's here. Electromagnetic wave equation. Okay, I think this literally does the derivation for us. But maybe we'll just go through the steps. It's kind of cool. Is this? Yeah. Is that what we're trying to build to? We're trying to get to that.
Yeah, what I just sent is the final result.
That's the final representation. Okay, cool. Yeah, no. This has to do a lot with curl and stuff, right? Okay. Yeah, because you have curl of E is a time derivative of B, but then curl of B is a time derivative of E. So yeah, this is a fun derivation. I remember doing this in like, what do we call it? I remember doing this in E&M. What's that class called again? E&M. No, it's not Schrodinger's wave equation. Yeah. Okay. Right. Okay. So, what we can do, we can look at this first one here, and we can take the curl of that, because then there's some rules for curl. Well, actually, interesting. Okay, here we go. Okay. So the curl of curl cross E, curl of E, curl. I always say like curl cross, but it's like the same thing. During the flat earther debate, he was arguing about like the existence of magnetic monopoles, and I was like, no, dude, like I said div dot b equals 0, but it's really just div b. I don't know. I just say it like twice, so I remember like which one it is. Big Bren says, "Oh wow, that's a lot. Would you care to speak when this could become reality? Seems to be 40. Wait, what? What are you asking about?" I put a lot of time into attempting to constrain information theory and put math under an umbrella. Don't put baby in the corner, dude. What? Don't try to put math in a box. What? If you understand what that actually will require, such as tons of complexity capture, would you care to speak? I have no clue, honestly. That's cool though. Thank you, Narosky, again. Yeah, awesome. I appreciate you donating your knowledge to the global consciousness of this live stream. Okay, here we go. Okay. Curl of negative dBdt, which is the same thing. If we pull out, I guess the operator can act on both of these things, right? The derivative?
Yeah.
Okay, cool. So this is curl of b. But we already know what curl of b is. Curl of b is equal to this fun thing, right? And I guess we assume that there's no time varying current. This J maybe?
Yeah. I would just assume that there's not.
Let's just get rid of this. We don't need to look at it. Just, this is what we call hand waving. We're saying, yeah, don't look at this, man. It's okay. Hide your eyes. Okay. So this is equal to negative ddt of mu naught epsilon naught. Oh, so there's another time derivative that pops out. Oh, this is cool.
Mm-hmm.
Oh, fascinating. Okay, so then this is equal to negative d squared dt squared. And then there's a mu naught epsilon naught out front. Which mu naught epsilon naught comes up a lot in, I think that's equal to c squared or 1 over c squared.
I forget exactly, but when it pops up in the wave equation, it's
I think
speed is the speed of light.
Yeah, I think it's 1 over mu naught
yeah.
epsilon naught is equal 1 over the square root of mu naught epsilon naught. I think that's equal to c.
Yeah, I believe so.
I want to say it is. I don't know what Langton's ants are, Big Bren. Okay. Cool. So we got that. And then maybe we want to look at doing this one, but taking the curl of this. Okay, because then we're going to get another curl E. Okay, cool. It's actually, oh, this is fun. I haven't done this in a while. Okay.
Well, we don't even need to look at that one.
You don't want that one?
Well, so if it's like a while back in calculus, sometimes ago, there's a nice property. The curl of the curl is equivalent to the gradient of the divergence
gradient
minus the gradient squared.
Oh, okay. Let me figure that out. One sec. Curl of a curl. Wait. Yeah, it's curl of a curl, right?
Yeah. It's that the go up on the one that you were just hovering over. It's that very bottom identity.
Yes. There we go. Yeah, you're right. Bless hyperphysics. I love hyperphysics. Yeah, this is the one I want. Okay, so because of this is the same thing as the gradient of the divergence of E minus div dot gradient dotted with itself,
which is just squared.
Okay, cool. That's the same thing as Nablus squared E.
Yeah, because if you were to take it and expand the dot products, the x-axis on the x, y-axis on y, z-axis.
Oh, interesting. Okay, wait. But then the divergence of E is equal to rho over epsilon naught, which is non-varying in space, right?
Yeah, or
is that where you say this is equal to 0? From this right here?
Yeah, because if you're doing it in a vacuum, there's no charge enclosed.
Sure. Oh, okay. Okay, okay. I like that.
That term just cancels out.
If in vacuum. I can't spell vacuum today. I don't know. How many U's are there?
2.
Okay, let's equal to 0. Okay, cool. Oh, okay, so then we get to the final answer here. Right, that nabla squared E is equal to this. And then I think we could come up with a similar one for B. I think B would be similar.
Yeah, we'd follow basically the exact same process, but with a...
Yeah. Oh, okay.
Different starting point, yeah.
Is this it? Are we done? Is this cool? Yeah.
Yeah.
You gave me a layup here today, Breasticles? Oh my god, thank you.
Yeah. I was getting out of difficult ones, so I had to take a break on the hard ones.
You're good.
They're basically the same to get the Laplace equation too, the Poisson equation.
The Poisson stuff we did was the most important thing I learned about that Poisson exercise is that Poisson means fish.
Yeah, I agree.
I was like, oh, dope. Poisson equals Poisson is French for fish, the fish equation. I think we also racked our brains a lot earlier today on the what was it that
on the triangle.
Fucking candy cane question. No, Pen Center, that's such a fun little ASCII fish. Nice, dude. Okay, let's see. We got a lot of the cool questions today. Let's go spin the wheel. Let's see what we get.
Let's go gambling!
Pineapple, lucky cat. It's you. Use the data points in the data below to determine a unique function. Ooh, okay. What type of question is this? Pineapple. Kind of fun. I'm going to give you 5 seconds. That's okay. Let me see. Narowski says, for context, Romania has a national 12th grade exam, some of the SAT called the baccalaureate. Every year, a student is allowed to attend a practice exam in the same conditions on the 24th. The math paper is provided for everyone to see. Okay. This is part of their SAT? All right, let's see what the hell they do here. What's in this land? I'm just curious what this is. Consider the function f of x e to the x minus 2 over square root of x 1. I think this means show that. This is the derivative. And then show the limit as x approaches 2 is equal to that. Determine multiple real numbers such that the equation f equals mx is an exact solution. Look, I can speak Romanian. Wow, I can figure it out. That's hilarious that this is their version of the SAT. The SAT in the US doesn't go past, I don't think it goes past geometry. I think it barely touches algebra 2.
Yeah, I was gonna say there might be a little bit of algebra 2.
Yeah, there's definitely not any calculus on it.
it.
There is no calculus on our SAT. The burger exam doesn't have any of that. Okay. All right, let's see. Okay. Determine whether the following function is odd, even, or neither, and explain your reasoning. Okay, very cool. So maybe we can use you're good, Pen. All right. Odd, even, or neither, right? Okay, so if something is odd, let's remember. This is the definition they tell you, and then I'll show you what it means. This means that f of negative x is equal to negative f of x. And then if it's even, f of negative x is equal to f of x. So what you can do is you can try plugging in negative x for everywhere you see x's, and then try to simplify it to see if it looks like the original function, and if it looks like the negative of the original function, or I don't know, the same function. So I'm just going to take this, and I'm going to plug in negative x instead. So I'm going to say negative x to the third over negative x minus 4 squared. And let's see what that would get us. So I want to try to have an x cubed up top. And what I know is that negative x cubed is the same thing as negative 1 times x. And all that is to the third. This I could write as negative 1 times x plus 4, I guess, right? And all of that's being squared. Okay. So then I can separate this. So I can act the cube on each thing. And then this would be negative 1 squared, x plus 4 squared. And so then this would become just a negative 1. So, and then this is, so we say negative x cubed, and then negative 1 squared would just be 1. So it'd be negative x cubed over x plus 4 squared. That's kind of like the simplest form for me to try to get it to look like this. Now, this presents a problem.
You done messed up, Aaron!
Because this doesn't look like the same function. It also doesn't look like the negative of it. So in this case, this is neither. Because this is neither the negative form of this, right? If we just had a negative up here, and it's not the same thing as the same thing of it. So that's how you can show whether something is odd, even, or neither. In general, it's kind of hard for rational functions to be odd or even. Following along for some relaxing... Yeah, nice, dude. Welcome back. Meep, right? Isn't Meep yours, is your Discord name? Meep? I love it, because I love the word Meep. Meep. Okay, does that make sense? Pineapple for the first part? In general, like, polynomials are a lot easier to make to determine whether they're even or odd or neither. You just look at the exponents. Yeah, I got the same. I was confused. Yeah, it's okay. If this doesn't look like the same thing, or it doesn't look like just the same thing times negative 1, it's neither. Okay. Use the data points to determine the unique function. Fascinating. So we're just supposed to fit this somehow? Okay. Equal to 1. Sensation. What's up, dude? One sec. Are you not a mod on my channel anymore? You should be, dude. What? One sec. Let me fix that. Yeah, there you go. You're back. You can... It was trying to, like, hold your things. I don't know why I was doing that. There you go. Okay. Oh. Yeah, no, the reason for that sensation is they put a temporary ban on my TikTok account because I said the R word, and they said it was hate speech when I was talking about myself. So apparently no self-hate speech is allowed. It said below, but it means questions 2 or 4. What's question 2 or 4? Sorry. It means questions 2 or 4. I don't know what that means. Okay. Do we want to, like, try to fit this maybe to something? It's kind of like my idea. Oh, this one is 4. Yes. That one is 3, but it said below. What says in the table below? I'm curious. Maybe I'm not understanding. I know the previous one we did. You're talking about Where do we do it? We did it somewhere. They're connected together. Maybe? Well, I don't see how they're connected to each other. Where was it? When did I do this question with you, Pineapple? I feel like it was recently. The hell? 2 days ago? Oh, maybe that's why. Yeah, right? Didn't we do it yesterday? Or not yesterday, but yesterday as in like the last stream. No, it wasn't the Fourier transform. It wasn't Poisson. Aha! It was this one. Yeah, I remember this. But wait, how does this connect to what question 3 is? That's what I'm curious. This just says use the data points. I get that it's like it's question 2, question 3. Well, okay, this is the table. This is the table below Pineapple, right? This is a table. I don't know why they put all this empty space here. Maybe someone can elaborate. Currently coming with a harder question for next time. No, don't do it. Breasticles is like, we're gonna hurt. There will be pain. I don't think this I think they just want us to come up with something. Beautiful Fembox. Fembox is just like, yo man, just x cubed plus 2x squared minus x plus 1. Crazy. How'd you come up with that? No, they're separate questions, Pineapple. Yeah, these are all separate questions. You figured it was probably cubic, yeah. So we can automatically see that it's not linear, right? Because there is no constant difference between the points. So that means it's not linear. And then if we look at the difference between the points, we can also see that the difference between the points is also not linear, right? Right, this would be 10. But the difference between the difference of the points is. So when this happens, this tells me right away that so if this was the same, this would be linear. If these were the same, this would mean quadratic. Because these are the same, that tells me it's cubic. Does that make sense, Pineapple? Okay, I see how we do this now. Yeah, okay. All right. And, okay, we know a cubic function is ax cubed plus bx squared plus cx plus d is equal to 0, right? Or not equal to, sorry, this is just, sorry, the function f of x, yeah. And at x equals 0, all these other terms go away. So that tells you right away what d is, right? So from this, so f of 0 is equal to 1. That implies that d equals 1. Great. Okay. To find the other ones, though, man. Okay. I see that -1 and +1 have to give me the same answer. How does that help us out? Well, okay, let's see that. Okay, wait, so f of 1, which would be equal to a plus b plus c plus 1, then f of -1 is also is equal to a plus So if it's -1, this is minus, right? So this is minus A plus B minus C plus 1. And these are all equal to 3. Yeah, okay, cool. This is actually really cool. So then if I add these together, right? This goes away. This goes away. And so you get 2B plus 2 is equal to 6. So 2B is equal to 4, so B equals 2. Cool. Okay. I like that. I'm a fan of that. So now I have ax cubed plus 2x squared plus cx plus 1. Aha. Now I think, because I only have 2 more unknowns here, Pineapple, I can use a systems of equations to figure this out. So we want to pick another, like, we want to pick 2 non-zero answers that aren't the same. Or actually -1 and -2. Let's do 1 and 2. I think 1 and 2 would help, right? Okay. So f of 1 is equal to, sorry, so f of 1, we already know, right? So f of 1 is going to be equal to a plus c plus 3. And then I would say f of -2. A plus c plus 3, right, which is equal to 3. Okay, this is very cool. Yeah, yep. So this tells me right away that a plus c equals 0. And then f of -2 tells me that -8a for 8, so plus 9 minus 2c is equal to 3 as well. Okay. But then a is the same thing as -c. So you get -8a plus 2a is equal to 3. Alright, this tells me a plus c equals 0, a equals -c. And then from this, -7a plus 2a. I don't like this. Ooh, something messed up. Something's messed up. Uh-oh. Wait, one sec. Hold, please. -2, one sec. -8. Oh, this is a 9. Dude, trust my A's and 9s to look the same. Oh, no. No. Okay, there we go. Okay, so then you get -6a is equal to -6. A is equal to A is just equal to 1. C equals -1. Bingo.
Oh, yeah.
Okay, so then it's x cubed plus 2x squared minus x plus 1, and that's it. Wow, very cool, actually. I like that one. That was a fun one. Let me know if that made sense, Pineapple. I know I probably skipped some steps in doing the algebra. Yeah? Cool. Yeah, that was a fun one. Don't worry, I'll figure it out. Okay. Well, if it ever doesn't make sense, you know, we'll, you got the test about this tomorrow? Oh, good luck. Yeah, good luck. That was a cool question, actually. I really like that one. Because at first I was like, wait, am I just going to, like, guess and check? But then I remembered. Thank you, Femvox, for reminding me that he's like, oh, it's cubic. And I'm like, oh, yeah, wait a minute. That would make sense. Check the differences of the differences of the differences. And then once you know that, it's figuring out, oh, well, what happens when x equals 0? That gets me the d. And then, like, then it's building a bunch of systems of equations. Yeah, you got it, dude. Nice. I do need to hydrate. Thank you, Sensation. Okay, I got 22 minutes. Let's see what we got left. What we got? All right, let's spin the wheel. See who's gonna win.
Let's go gambling!
Oh, let me give you a coin. My bad. Laplace, dude. Wow. With the 6.8% chance. What do you got me for me? What do you got for me, Laplace? Oh, nice. E&M. I like E&M actually. E&M's great. I'll see if I have time to do all these. There's a lot of parts to this. Yes, simultaneous equations for our across the pond friends. Wow, physics, man. We haven't done a physics question in a hot minute, dude. Okay. Yeah, I do like physics. Okay, cool. All right. An insulating sphere carries a total charge of 24 microcoulombs. Okay, plus Q. Concentric width is a thin, uniform, conducting spherical shell. Inner radius 2r, outer radius 2r, containing net charge minus Q over 2. Okay, cool. Okay, so it says use Gauss's law. Gauss's law says this. Integral of E dot dA is equal to Q enclosed over epsilon naught. So between 0 and R, so what we assume is that we're going to say spherical Gaussian surface. So the integral of E dot dA is going to be equal to E times the surface area of a sphere, which is going to be 4 pi r squared times E. Cool. So then the key thing is evaluating what's the charge enclosed as a function of little r in this case. Little r is your distance from the center of the circle here. And then this is an insulator. And it says it's uniformly distributed. This is very cool. Okay. So, how uniformly distributed means, okay, we gotta think about like what Q enclosed is. So, if the charge is uniformly, like it's spread out evenly over the volume of this sphere, then the charge you enclose is also going to vary as a function of like how much of the sphere you're enclosing. So we can say here that Q enclosed is equal to Q total. And then what I like to say here is like, this is the volume percentage. Where the volume percentage is going to be 4/3 pi little r cubed all over 4/3 pi big R cubed. Right? Because this is the amount of volume you're enclosing compared to the total volume of the inside thing. So yes, good. So exactly right. So then these all cancel. And so what you end up getting is that Q enclosed is equal to, in this case, Q total, which is big Q. And then we're going to say R cubed over big R cubed. Nice. Okay, so when you're doing your analysis here then, right? Okay, so for part 1, this is not too bad. You're going to say, okay, cool. E times 4 pi r squared is equal to Q little r cubed over big R cubed. That's the Q enclosed. And then all over epsilon naught. And then what I end up doing, right, is I'm going to bring this over. And that's going to get me 1 over 4 pi epsilon naught. So I'm going to like take these together. This is also a lot of times just called K. And then you're going to have Q. And then it's going to be little r cubed over little r squared. So that's just going to be R. And then it's all over big R cubed. So the cool thing here is that the electric field, so this is E. So this is done. It's linear with R. So as R goes out, you start enclosing more charge. You're further away, but your electric field goes up linearly with R. It's a fun question. Okay, so then the second situation is when you're in between here, big R, and the inside of this spherical shell that's enclosing it, which is, I think, 2R, 2 big R, right? Okay. So as you start enclosing more and more space here, you actually don't enclose any more charge. So this is kind of the cool thing. So Q enclosed in this region is just equal to Q. It's just equal to whatever the total Q is that you originally enclosed. You're not gaining any more charge as you get away from it. So here you can just say, okay, well, E times 4 pi R squared is now just equal to Q over epsilon naught. And then this will get you that E is equal to 1 over 4 pi epsilon naught Q over R squared. And then this is very cool because this is the same thing as the electric field for a point charge. So what this shows is that the electric field, when you're outside a sphere of charge Q, is the same thing as the electric field of a single really, really tiny point charge of the same charge Q. It's the same equation. It's really cool, actually. Okay, and then when it's greater than 2.2R. Okay, so here, maybe let me put some, like, so there, Q enclosed here, right? And then here, let me put, like, a different color for this. I'm going to say, like, from here to here, Q enclosed just equals Q. And then once you're outside, that's cool. So once you're out here, Q enclosed is equal to Q minus Q over 2. What if R equals 2.1? Yeah. Yeah, then it doesn't go as the cube, I think, right? Or is it still the cube? Is it still the cube? But it's like you have to do R minus R inner over R outer minus R inners. Like that, I think that's what you have to do. It's a pain, right? Yeah. If you were in between, I think the equation for that is it's R minus 2R. I think it's R cubed minus... No, it's R minus 2R... One sec. Let me think. Right. The total charge... Oh, it's a conducting shell. Oh, I didn't even read that.
Oh shit, not good.
Oh, okay. Yeah, actually, yeah. Q equals 0. Yeah, okay. E equals 0, because it's conducting. Yes. I was thinking if it was insulating, because then you have to do, like, R outer minus... You have to do R minus R inner over, like, R outer minus R inner, I think. I think that's the way we do it, right? Yeah, okay. Here, E equals 0, because it's conducting. Yeah. Electric field in conductors is always equal to 0. Love that. Okay, so then for this one, you're just going to get that E is equal to 1 over 4 pi epsilon naught, and then this is going to be Q minus Q over 2. Oh, which is just Q over 2. So we're going to say, like, Q over 2, 1 over R squared. Yeah, which is 1 over 8 pi epsilon naught Q over R squared. Cool. Nice. Yeah, E had to be 0 inside a conductor. It's because there's no charge enclosed. Right? The charges would always, like, try to occupy, like, one side or the other. Because they can move. There's no reason for them to chill in the middle. I think that's the reason. Determine the surface charge density on the inner and outer surfaces. Wow, okay. This is kind of fun. From what I remember, my brain's fried after so many hours of this. Okay, yes. There is going to be, if this is positive, that means you're going to have negative charge on this side and you're going to have positive charge on this side. And then the difference in the charge has to be negative q over 2, right? But then how much charge is there? Yeah, that's what it is. Yeah. Or I think we say, like, it's barely at the surface, right? Because conductors don't keep a charge, they get one, like a push button to charge the capacitor. Conductors definitely keep charges, but they keep charges on the outside. Okay. I think what we do here, Fem, right, is I assume I'm like, I assume on the inner radius of that spherical shell that my electric field is 0, like we're right past it. And then on the outer shell, I assume that the electric field must be equal to this, right? What it would be out, right? I think this is kind of how we do it. Yeah. I think we assume here that E equals 0. Oh, okay. Okay, actually, I remember what this is. Yeah, sorry. We assume it here, like right before the edge. E equals 0. And so Q enclosed equals 0, right? Yeah, okay. So we would say that E and yeah, let's think, so this is, yeah, that's it, right? Okay, so E times 4 pi r squared is equal to Q enclosed over epsilon naught, right? And so in this case, this is going to be E is equal to 1 over 4 pi epsilon naught. And then this is Q enclosed over and this would be 2.1 R? Or 2R. Yeah, no, E&M is great. Okay, this must be 0. But you have Q from the center. Perfect, right? So the inner must be minus Q. Right? Okay. That's right. This side must be minus Q. Yeah, this is physics. This is high school physics though. This is probably, I'd say, like AP Physics. Maybe it's AP Physics C though. But yeah, okay. So this must be minus Q in order for anywhere I build a sphere inside this to get a total enclosed charge of 0. But then in order to get an enclosed charge of Q over 2 when we're outside, and I'm gonna say, but to get Q over 2 enclosed outside, then the outer surface, Q must equal to 3/2. Right? That's the only way for there to be for a net charge. Wait, no, sorry. Q is equal to 1/2. Sorry. For a net charge of negative Q over 2. Yeah. For negative Q over 2 on the shell. Yeah. Okay. Cool. And then yeah, so the surface charge density, that's equal to, so inner is equal to this over 4 pi times 2r squared. Because surface charge density is equal to Q over area. Cool. Okay. So that's negative Q over 16 pi r squared. And then outer is equal to Q over 8. And then this is 2.2 r squared. So I don't know what that is. That's Q over 8 pi times 2.2 squared r squared. Yeah, this is wrong. Yep, my bad. Yeah, this is 1/2. Good. Okay, cool. All right. We could graph this. That's fine, and then we could do work energy to get potential. I'll save this for later. I think just in essence of time. I think this is, once you get this figured out, everything else is not too bad. Because yeah, now you have the charges. Now you have the electric fields. You can graph it all. Okay, cool. Great question though. Thank you, Laplace. Yeah, that's a very standard exam question for physics E&M. Okay. Let's see what else we got. Gladiator Lido, is yours gonna get picked, dude? Gladiator's like, where's my question, dude? Come on. All right, let's choose winner.
Let's go gambling!
Team Scrader! Wow. Okay. I'll work through these quickly. I can skip yours? What, because you already know this? Oh, okay. Let me see what you did. Mean and standard deviation. Your high school didn't have a physics class? What? Damn, man, that sucks. Okay. Alright, you should know that, yeah, outliers affect mean and standard deviation. Okay, that's all good. Okay, so you can skip mine. Alright, let's go back. Let's spin it again.
Let's go gambling!
Yeah, the base GRE, I feel like is easier than the SAT, honestly. It's not that bad of an exam. Alright, Iceland, Lumiere. There you go. Ooh, converting units. Oh, this is so super fun, actually. I like these. Okay, cool. Okay. Yeah, good luck on it, though. Yeah, good luck on the exam. Laplace says I hate electrostatics. Dude, electrostatics are great. This was a fun question, Laplace. Are you in a sorry, I saw you're in our YouTube. Is this are you in AP Physics C or is this like college physics? Also, if you ever had any questions about that question, make sure, if you're watching, the same place you guys go to submit the questions, we have a Discord. Make sure to go join our Discord, because that's where I post all the solutions. So, for instance, your solution, Laplace, I posted, is right here. So this is a nice little screenshot for it. And if you have other questions about the other parts, I'm happy to do them like outside of the stream. Just check them out. Okay. Converting units. Kilo means 1,000, so 2 thousands is 2,000. Okay. So in this case, this would be 4 kilograms, right? 4,000 grams, 4 kilograms. This is going to be 5,000. How many milliliters? This is 9,000. I love how they start putting fractions.
You done messed up, Aaron!
Like what? Okay, fine. So half 1,000 is 500. And then this is 15. 3,000. 6. Let's see if I can speed run this. 1,500, right? This is 1,500. This is 12,000, and then this is 1,500. I think I did it. Okay, which is the most? Circle the largest in each box. Okay, so I would convert everything to maybe milliliters. So this is 4,000 mLs, and that's the biggest one.
My man!
Did I do 5,000? Did I screw up somewhere? Oh, I did. Wow.
You done messed up,
Honestly,
Aaron!
don't go and do that, please.
Yeah, don't do that. That's wrong. I convert these into grams. So this would be 3,000. So this one's the biggest. And then same thing here. I would convert these into milliliters. This is 5,000. So this one's big. This one's the biggest. I said it right. Oh, I just drew it wrong. Yeah, that's my dyslexia. These are equal.
Oh, yeah!
5,000 is the same at 5,000 1,000ths is the same as 5. Oh, I guess I didn't describe this. Sorry. Milli means 1,000th. So there's 1,000 milli things in one thing. Yeah, actually, let's write that at the top here. Sorry. 1 kilo thing is equal to 1,000 things. And then I'd say 1,000 milli things is equal to 1 thing. So this is less, because this would be 9.2 kilo things. This is less. This is equal. Greater. Less. Greater. Equal. No. Less. There needs to be another 0 there for the equal. And then this is greater. Okay, cool. Nice. Speed run. That was a fun one. Iceland Lumiere.
Well done!
Yeah. Math and science are the best. We do love math and science. Okay. This one is done. I'll go a little bit over time because I feel bad. Gladiator, dude, you submitted almost 2.5 hours ago and your question still hasn't gotten picked. That's crazy.
Let's go gambling!
I guess luck just be like that sometimes, dude. Dude, what? Gladiator's like, bro. What? Oh, we already did this one.
Oh, yeah!
Okay, cool. All right, we already did this one, so I can delete this one. Okay. Okay, so Gladiator, we're gonna choose the winner. I hope you get picked here.
Let's go gambling!
What's up, Arya? You're very lucky today. Oh yeah. Congratulations. All right. Identify the different orbitals. Ooh, fun. Should have had JC on this earlier. To form NO3 minus? Okay. Okay. I'm just gonna look up the Lewis structure for NO3. I'm just too lazy to figure it out. Okay, NO3 minus is a double bond to one of them. Cool. I was wondering if there's like a lone pair or not. Okay. So then, the orbitals. Yeah. I think, this is going to be sp2 hybridized, no? What was it? sp2 hybridized? Because you have 3 different things bonding to it. You don't care like how many. It's the number of electron groups. It's not the number of things. Yeah. So the nitrogen. Let me see. And this is one JC did do this. Let me see where JC did this with us, because he provided a good answer for this. Yeah, it's sp2, right? Okay. So then you have, I want to say, sp2, and you're going to have 3 bonds there, right? And these are going to be the, is this the sigma bonds or pi bonds? And then you're going to have an additional one that gets, up to the 3D. This is for the nitrogen. All right. And then oxygen. I mean, oxygen is just was it 3p4? You think it's 2p? Yes. Well, okay. So nitrogen. Oh, yes. Sorry, this should be 2d. Unhybridized. Oh. Yes. Yeah. Sorry. Yes, because nitrogen on its own. Look at the periodic table, right? That's 2p2, 2p3. And then oxygen is 2p3, 2p4. And so the nitrogen is going to borrow 2 of the electrons here to create these sp2 hybrid orbitals, and then it'll have a 2p. And then the oxygen, I want to say it's just, these are not, these are just the 2p4s, no? This one is going to have, sorry, do the oxygens also form hybrid orbitals? And then this one also has a 2p hybridized orbital. I'll send one of my friends solution, but I don't get why they move an electron from nitrogen to oxygen. Well, because you want all the things to pair up eventually, right? It's kind of the name of the game. Also, here, we can send this at chat real quick. Just curious. Nitrogen uses 1 2s orbital, 3 2p orbitals. One 2s orbital, 2 of its 2p orbitals to make 3 sp2 orbitals for each of the pi bonds. Yes, and the remaining 2p orbital on the overlaps to get the pi bond for the double bond. All right, let's see what your friend did. Bella, what's up? Hey, you. K6000, right? One sec. Resonance structure. Yeah, wait, what? What's happening here? Okay. Yeah, no, I think they're just showing this, right? This makes sense. So, yeah, the nitrogen is going to form 3 sp2s and 1 2p. Each one of these sp2s is going to bond with, why does electron from 2s go to 2p in oxygen? Oh, interesting. Okay. Yeah, no, I see what you're saying here. And then in this one, they just say, "Oh, well, we have an extra electric charge because it's an ion." But then why does this one just this one just chills open? Okay. Yeah, what are these lines, dude? I've never done this in chemistry. This is interesting. I understand that this is going to need to bond with this. This forms the pi bond for the double. Well, one has an extra. Right. Well, this missing oxygen here is going to take is effectively going to be this. This oxygen is the same as this oxygen in terms of formal charge, because what it does is it effectively takes the extra minus charge you have hanging out to form this. What I'm confused with is, wait, how does this thing gain an electron suddenly? Look, do you see how here I have 2p? Oh, I see. But then, this one then gets promoted. Yeah, nitrogen. Yeah, I love all the exceptions in chem.
You done messed up, Aaron!
Okay. I don't think it matters which one. Yeah, I don't think weird stuff like... I've never seen this on a chem test. Like, usually you just need to know this. You just need to know that this is sp2 hybridized and that the extra electron is in the 2p shell, which allows you to form the double bond. I guess in doing so, right, this one had to lose an electron, so you might as well give it to one of these oxygens, and then this one, right, is going to have the same formal charge, so it takes the electron from the ion part of it, and then this one, the one with the double bond, will already have... I see, and then these are the two bonds it forms. Oh, very cool. I think I see how this works. It's cool, though. Yeah. Because then one of these gets promoted up here to fill this, and then one of these comes up here to be the 2p. And then these two matchy-matchy to make the pi bond. Do you have to really draw all of this? I think in general, you just need to, like, kind of show this. Yeah, we definitely we don't do this in like American high school chem. We don't show like how the individual electrons get promoted and stuff. Okay, well, cool. I mean, I'm glad you're understanding it. I mean, I think I get it. It's kind of cool. I don't know if I could reproduce it on a test. It works until it doesn't, dude. That is chemistry. Chemistry is totally like that. It works until it doesn't. There's exceptions for everything. Okay, yeah. In that case, just kind of like look at how they do it. I can understand why it works, but I don't know if I could repeat it on another test. But you're doing a good job by looking at previous tests and to see what the answers are. Because I don't even think ChatGPT talked about that. And Chat's pretty fucking good at chem, dude. Right? Yeah, Chat didn't even go that crazy. Chat's just like, yeah, look, well, whatever. Here, I could say, be like, but wait, aren't two of the oxygens only having single bonds while one has a double bond? So it should have a different energy structure. Wait until D and F orbitals are added. So, dude, this is Chat. Chat says that the key idea is that single and double ones are not real. The birds are fake. That's not the actual molecule. Wow. So Chat goes even further to say that pi bond is spread across all three NO bonds. Right, because it doesn't matter which one it's on. So in Chat's argument of chemistry, it says that those pi electrons are not specific to one oxygen. It's actually delocalized amongst all three. And yeah, this is the confusing thing sometimes in chem, is even this diagram is like technically wrong.
Oh, dang it.
It's not how it's an interpretation of it, but it's not how the world actually works. Yeah. And this is why I haven't seen this. I haven't seen this ever, and I've taught a lot of chem. I've never seen it explained this way. Life's a lie. Okay, cool. All right, I'm way over time. Let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours. Oh, appreciate everyone came by and asked questions. We had a lot today. Again, if you guys want to figure out when we're streaming and all that fun stuff, what? This just went away. Excuse me? Okay, I don't know. Anyways, okay, there we go. This website here, I like that. It feels right. Could any of those other atoms be any different from the others? Yeah, symmetry. Everything's in its place. Make sure, go join our Discord. That's the best place you can find all the questions we do, anything we didn't. I guess we had one more question, but I don't know if I have time for this one. Oh, why did we do this one? This one would have been great. Laying pipe, bro.
Nice.
May the chem. Yes. Good luck with chem. But anyways, I don't know. It's not loading. This website, actualofficehours.com. Please go join our Discord. That's where you can find all the questions we do. You can learn about all the fun stuff and activities we have. We have a chess tournament on Saturday at 3 o'clock. So come join that. That'll be fun. Click here also on the streaming schedule. You can see all the different streams happening. So we had Penn Center here. We had Zach. We had a bunch of other fun people. So it looks like tomorrow morning, Penn Center and Zach are going to be doing their podcast Beyond the Blackboard. And then Eric and Penn are going to be doing some cool simultaneous streams. And then we will be on again tomorrow. Same time, 5 o'clock. Cool. All right. Awesome. And then, yeah, if you found us on YouTube or TikTok, make sure to go watch us. Go follow us on Twitch. It's the better platform for viewing things in horizontal. And also, we can go raid channels. Like we're gonna go do right now. We're gonna go say hi to somebody. Let's see. Who am I following? I'm following so many people because I met so many people at TwitchCon. Oh, someone else has a spinner wheel. Sub equals spin wheel. Dude, someone else is spinning a wheel. I don't know who this person is, but I must have met them at TwitchCon. Mary is streaming. Okay, let's go say hi to Mary. I do like Mary. Yeah, it's been a while. Ooh, wow, what is Mary building? Okay, go say hi to Mary. He's a great electrical engineer person. So if you have any electrical engineering questions, Mary's dope. Cool. All right. Enjoy the rest of your Wednesday. We will see you tomorrow. Peace.
I didn't know that. I learned that recently. I thought fishing was like so cool. You go with your fishing rod. It's awesome. Nah, it's fake, man. Oh, we got a real streamer coming here. That's good. Educational streamer. Fembox. Long time no see. Yeah, dude. Yeah, bring him to the CTSA. He's right. Yeah, let's see how